cover advanced locking mechanism in Java, completable future, also fork join pool, and custom synchronizers. In the previous session, it also was here. So we covered synchronization with logs, thread management, concurrent collections, and atomic variables and non-blocking algorithms. So yeah, let's get started. Advanced locking mechanism in Java. So as a part of this topic, I want to cover reenter, read-write lock, and stamped lock. So reentrant read-write lock, it's belong to the lock packages and implement the lock interface. So reenter read-write lock allows multiple reads and exclusive writes. Key concepts that read lock is shared and write lock is exclusive. Why reentered? Maybe someone knows and can answer this question. Yeah, exactly. So yeah, why it's reentrancy, meaning that the same thread can acquire the same lock multiple times. So for example, it could be use case when you extending from the parent class and you have a method from in parent you have lock and you have in child class lock, and when the you acquire the lock in the child's method and then you're recording the parent method, thread will automatically acquire the second lock. Why it's done in Java to prevent deadlock. How it is implemented in the level of Java. So basically, there is a counter which is extended by queries, and when this thread is releasing lock, it's also decreasing the counter. And once the counter is 0, then it's counting that lock has been released. Yeah. There is some example of code. Reenter C. This is not like this is just basically a method, which is first we acquire read lock, then we requiring the second time. So yeah, and then you need to unlock the nested lock and then the second one. Okay, moving on. What is the advantages of reenter read-write lock? So first, it's increasing concurrency because the read threads they share it one lock. Means you can have 1,000 threads which is having the read locks, which is having the read lock. So this is one advantage. Second advantage is reenter read-write lock supported fairness options. Fairness options we discuss also as a part of Java concurrency part 1. So basically, it's idea that locks will be acquired in the order when it was requested, and not in random order. Reentrancy that it's supported, and and also reenter read-write lock prevent in some degree deadlock possibilities. Moving on, so use cases where reenter read-write lock can be useful. So it's apparently in the high read and low write scenario to the shared resources. So it could be a cache where you mainly reading values from cache and there is low writes. The same things for database when you're mainly reading database rather than updating it. Some performance considerations and pitfalls. So overall, it's all about you should use reenter read-write log only if your system is read heavy, because otherwise it doesn't make sense to have it in the system where it is write heavy, because there will be anyway contention for the log between reads and writes. Yeah. So stamped log. Stamped log is similar to I think it's similar to reenter read-write log. So, but with additional features. So it's also have read log, which is shared one, and also it has write log, which is the exclusive one. But a part of it, it's also has some advantage features, which is optimistic read locking, and it's also allowed to upgrade and downgrade logs. Means you can upgrade from the read log to the write, and from the write you can downgrade to the read. And also one important thing, which is I didn't mention, I forgot. So it's introduced a concept why it's stamp log, because it has stamps. Stamps basically it is a long value which is representing the version of log. Where it used? It used mainly in try optimistic read. It's a stamped log supporting also optimistic read. When you're not acquire any log, you're just reading, and you evaluate the stamp, and if the stamp is changed, so basically then you're going and explicitly acquire the read log. Or as in this example, you're explicitly acquire the write log if the stamp has been changed. So yeah, how the optimistic locking is working. So when thread acquire is optimistic read log, it can proceed without waiting the read log, as I mentioned. But once it's checked, it should be fallback to the acquiring the read log by checking the stamp. So let's take a look at the upgrading scenarios when it's useful in downgrading scenarios. So this is one is upgrading a read log to a write log example. The main benefit for this, so yeah, the main benefit. So for instance, a thread holding a read log. Optimistic and upgrade to. So the main benefits between the upgrading a read log to a write log. Let's starting from the main benefits of downgrading. Yeah, because I mismatched my slide. So the main benefits from downgrading a write log to a read log. So for example, when you have a block in your code and you need to make the changes, you basically acquire the write log. And the shorter your block, where you need to change the changes on the shared resource, then better. And downgrading from write log to read log, it's actually helping to optimize the performance of your application, because then earlier you release the write log, then earlier the rest of threads will be able to take to acquire the lock, and there will be less contention between the locks. This is the idea of having downgrading and upgrading locks. Best practices. So yeah, only upgrade when necessary, and it should be a very short lock, the same like we have with synchronizer block. Then shorter synchronizer block than better, less contention for the lock. Also, it's the best practice is to use try cover to write lock and try cover to read lock. This is why explicit. On my example, there is the explicit locking is lock dot write lock. This is counts to be explicit. Means when the thread calling this method, thread will be blocked until it will have chance to acquire the lock. But if you're using try cover to write lock and try cover to read lock, you basically we are calling it asynchronous approach. It will return you immediately whether true or false, whether you you was able to acquire lock or not. And with returning right away answer, so thread not blocked and can do the other things. So also best practices is avoid deadlocks. So it's a bad practice when you're holding multiple locks and trying to acquire another locks. It could lead to deadlocks. And yeah, as I mentioned, use downgrades, downgrade as soon as possible. This is the best practice. There is some comparison between reenter read-like lock and stamp lock. So basically, they are very similar. A part of that, the stamp lock supported some advantage features with stamp and allowed the try optimistic lock and also downgrading and upgrading locks. But in general, they're quite similar. Moving on, so completable future. Yeah, so completable future, it is completable future extending future and represent a future result of asynchronous computation that can be manually completed. The key features of compatible futures, you can manually complete or just complete with exception. Also, it's supporting some chaining and composing tasks. And also, it's providing non-blocking operations, means the threads are not blocked while they waiting for result. And exception handling. So you can add custom handling exceptions. I will show it in next slide. Okay. So yeah, how we are creating future. Future is supporting two types. So it could be created with supply sync, or it could be created with run casing. So the difference is that the supply async return a result and run casing doesn't return result. This is the difference. This and below examples how we can create a completable future. This is another example. Okay, so moving to the chaining operation. This is the most powerful feature of completable future, and it's so its ability to transform result from one task to another, and it's done in non-blocking fashion. This is some example of code how we can use chaining task. So we're creating the future object, then we are waiting for result. We're doing some other operation, then some others, and we are actually returning the result. Compatible futures, so supporting also multiple futures. You can create a few futures, and you can either wait while they finish all of them or any of them. I will show some examples where it is useful in some real world use cases. Exception handling. So it's also very powerful features. It's allowed you, so in case of, if we're using exceptional, it's allowed you to handle the exception and provide the fallback value. Or it's handle both, like result in exception. It's also very powerful feature, similar to what we have in Rust. So that's why, yeah, it's one of the powerful feature in Rust when it can return result and error. And there is similar things in Java as well, also supported. And so some examples how we can handle both result and exceptions. There is something new which was added in Java 9, not really new, but yeah. So you can actually specify the timeout. For example, if your result is not wasn't returned on time, you can specify the timeout and handle the exception in order to not handling forever. Real world use cases. So this example, how you can asynchronously doing database queries. So basically, you're creating two objects, completable futures, and you run them, and then you are combining them and returning the result. Similar, we can proceed. We can work with files, also creating some tasks, and then waiting all of them for the completion and provide the result. Or parallelizing some IP calls. Yeah. So to conclude, completable future is extremely powerful. So yeah. It's a lot of use cases where you can use it. Some of them I showed already. Some of them it's like web scraping or data aggregation. For example, yeah, perform multiple web requests in parallel. You can, or task scheduling, or in parallel data processing. Okay, so moving on. There is fork join pool. Fork join pool. It is so it's a special executor service. It is a special pool which is introduced in Java 7, optimized for parallel execution of tasks that can be recursively split in the smaller one subtask, and then can be combined. So the most this fork join pool is built based on work stealing algorithm, which is I will cover in the next slides, and I will explain how it works. So the key concepts of work join pool is forking, and so meaning you can split your task in smaller tasks, and joining, combining the results from the subtask, and work stealing algorithm. When the idle thread can basically steal task from others thread to balance the load and to utilize the resources on the machine. Okay. Let's explore work join pool architecture. So the foundation, as I mentioned, is work stealing algorithm. Each thread in work join pool has their own local queue where all the tasks is queued. So, and once if one thread is finished task and his queue is empty, he is able to steal some task from the other queues of other threads. So it helps ensures that the resources are fully utilized on the machine and no idle threads. Okay, this slide will be a little bit repeating. So worker thread, as I mentioned, will steal task and yeah, to maximize CPU utilization and yeah, no idle thread. Fork join pool supporting different tasks, recursive task and recursive action. Also different, one is a returning result, one is not. Yeah, and there is some examples I want to show. So this is the examples of parallel merge sort, how it is implemented. So here, so the idea of this merge sort algorithm is you have a huge data set, and you need to sort it, and you will split them on the subtask and doing some sorting until, and then you will combine and merge them. So this is the idea which is, could be applied to fork join algorithm. Here we are splitting them on the task. Here we are creating for each task a new thread, and we are waiting while the thread will be finished, and then we combine them. So this is the example. I think there will be more. In this example, parallel searching. So basically, we are creating a task which is extending recursive task, Boolean, and here we are creating we're creating the pool and task. So we are basically invoking it and doing the search. Another example. So when it's when not to use a fork join pool. So basically, fork join pool won't work with one second, please. So EO-bound task like handling HTTP request or database query. So short duration task like a meeting log or task which is has shared which is required to modify shared state. Also not splittable task. Moving on, so parallel streams in Java. So I think most of the people already used it. It was introduced in Java 8. So basically, it's extension of Stream API. and it could be invoked with parallel or parallel stream. And so the idea is that the parallel stream is actually used for joint pool underneath, for parallel, for splitting into chunks all the tasks, and then apply some actions by chain operations and return the task. So as a part of parallel stream, you can, in order to optimize the parallel streams, there is also exist default splitter, which is defined at how you're going. The parallel stream is working with collections mainly, and if you need what is the fork join is doing? Fork join pool will split your data set in the chunks, and for this reason, there is a default splitter. But this splitter could be an override, and you can split your data set in custom way as it needed for your system. This is the example, just very simple example. What is the parallel stream? So we have list here. We are working parallel stream. We are filtering, mapping it, and returning the result. Yeah. So when to use use parallel stream? When there is independent data, CPU bound task, and large collections. It also doesn't work with shared resource, because otherwise all the threads will be wait, and there is won't be any improvements in from the angle of performance of advantages of the concurrency. How to optimize parallel stream? So because it's using fork join pool underneath, and fork join pool by default configured configured the way that it will spin up so many threads as many threads as many cores you have on your machine. But you can actually specify by the command how many threads you want to have. Also, as I mentioned, there is splitter, which is by default splitting your data set in the chunks, but you can customize and using your custom splitter. Also, avoid shared states and evaluate performance before using it. Why? Because there is sequential stream and there is parallel stream, and I will explain now on my example. So this is the pretty simple example where we have very small data set, just 10 elements, and we need to perform some straightforward calculations on them. And there is the output. So in this case, as you see, sequential time is less than parallel stream. And why so? Because when you're invoking the parallel stream, you're facing the overhead. Because you're using the fork join pool, you're spinning up threads, you're also splitting into chunks your data set, and this overhead will return as a increase in time. So when not to use the parallel stream? With small data set, with stateful operations, with sequential dependencies, with bound task again, and when there is thread contentions. So for example, what I mean under thread contentions, that your system already has a pool of threads, like 3,000 pools, and you're also using the streams, which is underneath creating even more threads with fork join pool, which is creating the thread contention on the machine. Okay, so this is the last one. A custom synchronizer. What are custom synchronizers? A custom synchronizer, so it's basically a synchronization mechanism created to meet the specific needs of a concurrent application. Custom synchronizers are typically built on the top of basic synchronized mechanism, which is Java provided. It's log, conditions, or re-enter log. Where custom synchronizer can be useful. So if you need, as I mentioned, optimize synchronization in your application, or you want to extend existing synchronizers to meet your application needs, such as, for example, countdown, lodge, or semaphore, or cycling barrier. Now I will show an example where it could be used. So one of the common use case of custom synchronizations, it is rate limiter. So imagine you're having service that needs to handle a high volume of requests, but you want to limit the number of requests that can be proceed in the given period of time. That's how the rate limiter is actually working. So it could be used the semaphore for this reason out of box, but it could be customized. Let's dive deep into examples. So on the first slide here, we are defining maximum request. We are defining time window in milliseconds. So yeah, we're introducing the custom synchronizer log. And in next slide, here we have here as a part of acquire log. So basically, as acquire method, acquire request. Yeah. Acquire request. We are introducing time check, and if it's allowed, so basically we are request can So if it's allowed, so we are so the method if the request count exceeded the maximum, the idea of acquire request. So the method block at thread. 1 second. So yeah, acquire request. In acquire request, we're introducing the mechanism which will be track the check time and request count. And if the in this time window we are allowed still to the request is allowed. For example, based on usually rate limiter working with IP or with some customer identification, or and if on this dimension and on particular window we are having enough, we can allow the request, so we will basically acquire the log, and the request count will be increased. And then we're after thread is finishing its processing, so it is release the slot over there. Here we're using a synchronized block, again with log on the log object which we introduced in the beginning. And here we are saying that request slot is available. So this is basically the main method, how we can create the rate limiter and create some threads. Wait. So advantages of having a custom synchronizer. in particular this case, what is the advantages over the using semaphore? So we have flexible rate limiting. So it is not like unlike in the build in semaphore, which would only allow a fixed number. Also, time window management. A custom synchronizer also precisely control over the time window and request count, resetting periodically and ensuring that no more. It's over here that there is no more than allowed number of requests are processed. This something which is you not you won't find in semaphore built-in implementation. Yeah. And yeah, when I'm saying about flexible rate limiting and time window, so basically when you're spinning up your rate limiter, you can provide these parameters dynamically at the start. So yeah, that's it. Thank you. So any questions? Yeah. Notify poll? Yeah. So yeah. 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 No, I'm thinking whether there should be notify all. I was thinking, you're not going to be waiting for an acquire. Is no one not going to get stuck or acquire? You mean on which road where the request count is? Yeah, so you're waiting for request count to reduce. So the only time that happens is acquire. Yes. So do you not run the risk that if the acquisition stops, you have one? So let's take a look. So here, might be wrong, it's been a long day. Yeah, here we are entering to the synchronize log, to synchronize block, which is we are synchronizing on the object, on the one object. Yeah. Yeah. So for example, yeah. Request count. Yeah. There's only one place where that gets set back to 0. It's here, request count. Yeah. And so that only happens when somebody's wanting to acquire permission. Yeah. Let's one by so thread is come and so we acquire the log. Here, first check on the window. If the we passing window, then we are here setting it as 0. Next. So let's say that doesn't happen. Yeah. Yeah. Check if the current time window has expired. If it's expired, then the setting is at 0. But imagine that it's first thread, which doesn't have any rate limiters. And here we are actually checking. Yeah, if request count is like 0 or not, then it is still 0, right? Then we are not going to come here. And we will increase the request count. It will be 1. So and thread will proceed. Then thread will comes, and it doesn't fall in this in this check because we're still in the same window. But here, for example, we have rate limiter. We allow just 1 request at 1 minute. Then it will come here, and this request will be handling in this loop forever, and not forever, but yeah, I think it will be forever actually. The request count 1 and 1 log wait. Yeah, here we will be wait, and then method to release a request notifying the waiting time. Let's see how. So basically, yeah, first request will be handling here, log wait. And then let's sleep. It should somehow, yeah, I think it will be handling here forever. Yeah. Yeah, need to revise this example. Thank you. Yes. Yeah, you're right. It will be. Another thread will come. Yes. Yeah, yeah, yeah.
When another thread applies, then the time is outside the time window, so we can reset the counter.
Yes.
Then the previous thread.
Yes.
We need like a time waiting timer.
Yeah. Yeah. Right. Because I was writing a few examples, like not a few, tons. Yeah. Yeah, I wanted to just to show in actions, yeah, because just to having text without to showing the code is like yeah, very boring. Even though I feel that it's very boring, but Java concurrency is quite boring topic if you're not so you need to dive deep. Yes. Mm-hmm. Yeah.
Is there only one thread waiting?
Yeah. Yeah. No, I think when it's notify, it's just notify, and it will randomly choose one thread. That's how it works. Yeah.
It's possibly what you want, isn't it?
Yeah.
Because when you release one, it's only going to be opportunity for one other.
That's why I was like, yeah, questioning. I'm not sure whether we need to notify all here actually.
Wake up one thread still in that loop, yeah, because of the while, then won't, yeah, the ones that wake up, you need to wake up the right one.
Yeah. Why did I? Yeah. Any other questions?
Yeah.
Yeah,
is
sure.
there like practical ways to write tests for code, like line on?
To reproduce some to work for concurrency environment, you mean?
Yeah.
There's a guy at JetBrains who's working on something. I can't tell how it works. Or like.
A few years ago, there was a session. It was actually about the testing. I don't remember the use over there. Definitely, I might go back and check it again. I actually know. So definitely there is, yes, like you do, I don't know, let's say 1,000 runs and see if there is any, for example, rights conditions, stuff like that happen. So there are tools for that. But
You often want to like try and deliberately cause them rather than sit around waiting. Bytecode injection, you might be able to do that.
Which one?
It's some bytecode injection on the unit test. Force it down in a particular scenario. Is that the way that the tool view was thinking of?
no, there's specific, tool which automate that, as again, like, I don't know, runs, and they probably it was like a different path from if they of scenarios, yes. Now they would be, I don't know, trying to access the same resource from to right at the same time. few years ago, it was about testing, and it was the tool which helped us.
You can write the unit test with the thread. Submit a task, and then you have the countdown latch at the beginning, and then you submit 100, for example. Combating it.
Mhm.
And more or less find by getting
We have some internal tool, but I don't remember exactly. But yeah, some services has some internal tool, but I don't really remember how it works. But we like yeah, don't have specific test which is covering it. I mean, like unit test or something.
So that is kind of like a good time to promote Java's Slack workspace, where asking questions like that, like to continue conversations like that. So there are people who are today, but they might answer answering questions like that.
Stamp log, no, but I can Google it. 1 second.
Did he say I'm moving around that?
Yeah, I'll also open it for myself. A lot of things. Yeah, Java 8.
Then you can use the compliance swap, right?
Which one?
Compliance swap?
Yes.
Yeah, right. So you have some kind of like version video, right?
Yes.
You only do compare with something, right?
Because compare swap, it's considerable. It's used in collections, right? Mainly, and it is yes, it's without lock. It is it's how and that's why it's also used in many collections in order to improve the performance. Yeah, it's not a lock, and not mechanism. Compare and swap, but compare swap, it is not a part of concurrency. So there is stamp. Why we have this stamp here as a part of stamp log? It is basically it is just helping. For example, you have this read optimistic log where you're not acquiring the log at all. You are just reading, and then you are checking the stamp whether the stamp has changed. If it's changed, then you falling back, you acquire the read log explicitly, and you're reading. Or and you're reading means when you acquire the read log, no writes are allowed at this time. And that's how you will be sure that while you're reading it, so basically you will read the right version. With using? Yes, exactly. Yes. Yes. Because you optimistically, you are just why this. So basically, this they read optimistic, which is what? Yeah. Not stamp. No. There is different. Stamp log is providing optimistic reading, where you're not when you're not taking the log on the read. which is shared, for example. But if, for example, write needs to acquire the lock, it will be wait while the read lock will be released. In order to improve the performance, for example, in not acquire any locks, you are doing optimistic reading, read optimistic lock. You are reading, and for example, at some point before doing something like when you exactly need to know whether the changes was changed during your read or not, you are checking the stump. And for example, because you didn't actually acquire any lock, there could be some write which is happening at this time. Then you validating the stump and stump saying, hey, the version has been changed. And you can fall back and acquire the read lock, which is will be assure you that now, if you retrying your iteration, nothing will be changed during this time. Does it make sense? You can? Yeah, you can. Yes, yes, yes. Yes, yes. Yes. This is like just some built-in feature which is working out of box, but yeah, you can add your logic. Yes. About what? Parallel streams.
I was like looking into this, and I thought, are they, how do like that happen? It's to the architecture, like the American architecture, and I discovered the artwork, the way it's different. How was that least in Java 8? Do you know if it's changed or if there's other things that actually
Instead of 8 threads for parallel processing, yeah, I did mention. I didn't try, but it seems you can use this command to define how many threads you need. Yeah, here. It's maybe you have 8 cores on your machine, that's why it's always 8. I don't know. Yeah.
Was it 8 on an 8 on machine? It was 8? Okay.
Oops.
Sounds like you have.
Some other question.
ways to learn along the way. So you start with the pain, you find a solution, and then you find the next problem.
Which one? Can you repeat? Yes, yes, yes. 1 second. So this is the handling exceptions. Yes. So basically, let me see. So here, in the first example where we have exceptional, we can fall back to the default value. But I believe with handle, we also can fall back to default value as well. Yeah. So if you fall back each exception and allow you to provide a fallback value, handle both the result and the exception, if any. For me, it's the looks. So in first example, you're handling just exception, but here you're handling exception and you're handling a result. Yeah. But anyway, I don't see the reason using exceptionally, because handle is providing both. And in this example and in this example, you will receive results. So just in this example, when you will receive the result, so you will proceed with your chain operation. And let's see. And here will be the same. You just explicitly will return result. It's a good question, actually. But I don't have answer for it. But for me, it looks that they both doing the same thing. Yeah, absolutely. Yes. Yes, the very basic one. Yeah. Yes. Yes. So, for example, if you need to add some additional conditions for your, for example, I don't know, like in the rate limiter, right? So basically, instead of using just a clear semaphore where you can't provide additional condition, so basically you will implement your custom semaphore. I mean, rate limiter underneath, and using with based on primitives from the locking, which is notifiable, or this is pretty basic example. So there is you're just using lock and using wait, and this is just an example. But for example, if in your system required some additional conditions or parameters, for example, to handle some what I was looking into, I don't remember. I think it was also implementing custom semaphore. So, for example, to acquire some lock, there was additional check on the permission, whether you at all can have permission to these resources at all. For example, from database perspective, you're receiving some request, and the system needs to identify, even before to give you permission on the connection to database, whether you have the permission or not, and it could be rejected or granted you lock. So this is kind of use case. Yes. No, we just discussed that probably notify all is better. I mean, this was just an example. Yes. No, like background choice. This example.
I love the discussion. You can still continue it. There is a pizza and pizza for the like. So please continue discussion.
Thank you.
And I think you love the pizza.